Viewing LiDAR online, presented by Adam Derringer from AIRS. Adam joined AIRS Geospatial Operations in 2013 as a project manager and has 19 total years of experience. He excels in project design and management, client relations, problem solving, bidding, estimating, budgeting, cost reduction, and staff training and development. Adam has consulted worldwide on GIS department best practices and workflows, and he is the recipient of an International Esri Special Achievement in GIS Award. He has had extensive experience with geoprocessing, scripting, modeling, and data conversions. Adam is a WLA past president, chairman of the 12-member Wisconsin Land Information Council, and a board member of the Esri Wisconsin User Group. Take it away, Adam.
Yeah, all right. So sorry about that introduction, Kelly. I will, Shelly, I'm going to make sure that bio next time just says, this is Adam. It's a mouthful. All right, so I'm having a few tech issues. I shot into the office here, but I do have my video queued up. I'm going to be monitoring this and I'm going to run through it real quick. And then I'm still going to try to jump over to a live demonstration when we are done with this. I'm going to share my screen. You guys see the PowerPoint?
Yep.
Well, good morning, everybody.
You hear that?
Welcome to WLA on this lovely Friday morning. I'm happy that you all had the chance to join me here this morning. Today, I'm going to talk about viewing LiDAR online. I've been in GIS for quite a while now. Before I came to AIRS, I had always found using large imagery and LiDAR data sets very difficult to use. I remember in the late 90s and going into the 2000s, it was a really big deal. In fact, WLA was giving out awards to counties for being able to get county-wide imagery data sets online on these web maps, through ArcIMS. It was an incredible thing. And now online imagery has become ubiquitous. Everybody understands how to use it, both in land information departments, other county and city departments, engineers, but even the general public expects to be able to find this data, with a municipality or a county. I want the same thing to happen with LiDAR. It's an incredibly important data set, but very few people really have access to be able to utilize that data for all that it's worth to make better decisions. Today, I'm going to give just a little bit of background info. We're going to talk briefly about what is LiDAR, why is it so important, where can you find LiDAR data here in Wisconsin, and then talk about why it's so dang hard to use. Then I'm going to walk you through a LiDAR demonstration, and in that, I want you to understand that LiDAR data can be just as easy as imagery data and allow people to utilize this data as it should be in order to make better, more informed decisions. So well, this isn't really Adam, right? Not right now. This is COVID Adam. I am a bored COVID citizen trying to find things to do. So I picked up running, including in 0-degree weather. Yeah, so a little different than most of you probably recognize seeing me. I've been doing GIS and related technologies for about 20 years now. I've spent all of that time within WLA. I'm a past board member, past president. I still serve on the WLA Foundation. I help direct the endowment fund that we're trying to get fully funded right now. I also serve WLA as the Land Information Council representative from WLA and the professional GIS section. I've been on the board at EWUB for just about as long as I can remember. So educating and sharing of knowledge, sharing of data, this is really something that hits home to me. It's one of my favorite parts of my job. And it's actually one of the reasons that I work where I do at AIRS Associates, where we're advocating for better data, standardized data, freely shared data. So AIRS in general, we are an architectural and engineering firm, but we happen to have a geospatial division. It's actually quite large division. We have about 60 people between land survey and aerial mapping units. We do all sorts of survey. I mean, traditional survey. boots on the ground as well as scanning. And then we do mobile LiDAR. What I focus on, most of you know me for, is aerial imagery and aerial LiDAR, and that can be from fixed wing aircraft, professional UAS systems, helicopters, and I help manage the WROC program here in Wisconsin and write a lot of the LiDAR grants for the state of Wisconsin and advocating for those federal dollars to come help pay for these big projects. So what is LiDAR? Today we're going to be talking about specifically airborne LiDAR, primarily from fixed wing aircraft. So we're talking about wide area mapping, these data sets that are going to be used again and again and again over the course of 5 years, 10 years, and even more. LiDAR stands for light detection and ranging. It works like sonar or radar, but in this case, a sensor from a plane shoots down a laser pulse down to the ground. That laser pulse hits a surface and it reflects back up to the plane. And when you do that millions, even billions of times, you can pull out super high fidelity surfaces or asset mapping and things of that nature across wide areas extremely rapidly. This brings a lot of benefits in the wide area mapping. Most of this work started in the flood risk management area. Federal agencies, state agencies, and counties wanted to collect this data so they understood where water's coming from and where water is likely to go. People use LiDAR data for infrastructure management in corridor type mapping and wide area mapping. Where are buildings, where are utility systems, things of that nature. It gets used in construction management, making sure that construction is happening as planned. Where did we move earth from? Where did we move earth to? Natural resources conservation, it gets heavily used in wetland mapping, stream mapping, forestry. Agriculture uses LiDAR data in order to understand drainage. Where are we going to need water? Where are things going to flood? Precision ag takes that to a whole nother level of where do we need to place that water? Where do we need to place that chemical? What are we dealing with runoff or erosion? Gets used in water supply issues, especially as you go out west into drier territories. Where can we capture water from? Where can we retain that water and hold on to it for use over the course of the year? LiDAR gets used a lot for water quality studies here in Wisconsin. If we're going to have a farm and we're going to dig a pit, what impact is that going to have on water quality? Where are we going to have runoff? Where are we going to have potential issues? Where can chemical runoff get into our drinking water? It gets used in wildlife and wildfire management and planning, as well as response studies. The federal government regularly does studies on geospatial data, and LiDAR data is one of the most highly valued data sets. This study is old. It's actually being redone right now. The national study had said that about $690 million is annually recognized from having LiDAR data. It has one of the highest return on investments of any data set. So every dollar that the federal government spends on LiDAR data, they feel that they are getting $5 back in return, a 5-to-1 ratio. When the new study comes out, we're expecting that number to go much higher because the LiDAR data is being used for so many more purposes than it has in the past. It's only increased that return on investment, both in the public and the private sector. So I talk a lot about what other products you can do with your LiDAR data. You want to increase your own return on investment. Why are people getting these data sets? Well, very often it's the products that you can get from that base data. I know at AIRS, we regularly are working on upgrading people's hydro mapping. This could be ponded and flowing water, but also for things like updating the national hydrography data set. Many of those data sets were created in 1940s and 60s, 70s. They really haven't been touched since. Not only are they spatially inaccurate, but the streams change over time. We often map 2D buildings, and as we get higher and higher point density LiDAR data sets, we're doing a lot of 3D buildings as well. We're mapping tree canopies for forestry units. 1-foot contours are extremely common derivative out of these data sets for use in CAD applications and cartography. We run a lot of culvert inventories. Culverts are a critical asset for multiple departments, both from a transportation standpoint as well as for water modeling. When you have culverts, you can also create a hydro-enforced DEM. That is a surface of the earth that removes these what we call digital dams to allow water to flow where they would. We do slope analysis. We're doing erosion susceptibility mapping, zoning analysis. We map a lot of closed depressions. We're trying to find these bowls, these natural bowls on the surface of the earth where water is going to collect. That's important for thinking about where we may or may not want to build, but it's also important if we're thinking water quality. We want to find those bowls. That's very likely a potential natural recharge location that's going to be important for water quality. We do a lot of asset mapping as well. Depending on the density of the LiDAR data set, again, you can pull anything from large features like buildings and trees like we're talking about, but you can get down to things like poles and even curbs. So where can I get LiDAR data in the state of Wisconsin? Well, we've been pretty progressive. In Wisconsin, we started collecting countywide LiDAR data sets back in 2002. That really picked up speed in about 2005, 2008, 2010 to 12. We had a lot of big collection going on, and then again pushing through 2015, but many of these were locally led. The end of 2015, there was a federal program called 3DEP. 3DEP is using standardized LiDAR quality standards. Specifically, they look at quality level 2 LiDAR, which means 2 points per square meter. AIRS has helped lead the charge in organizing counties for this grant application every year since. So we've gotten to a point where the vast majority of Wisconsin is covered. In fact, we've gotten LiDAR coverage across all of Wisconsin in 2019. But it continues. The landscape changes. We need better, higher fidelity data. So people are continually upgrading their LiDAR data, and many people want to get to this new federal standard. And there's several counties that aren't there yet. 8 of them are going to fly LiDAR data in spring of 2021. So we'll be processing that out and adding that back into the national map. And the hope is to complete quality level 2 or higher across Wisconsin by 2023. So all that data is going to be open. It'll be available through the feds and very likely through the state, if not the counties as well. So anybody can get in and use this open data for their business purposes, be it in the private or the public sector. But it is a ton of data. If we go back to the original data sets, several of the counties have not been able to update their data yet. Many of them exist at, say, a quality level 3 specification. It's a great specification. It was co-developed with Wisconsin DNR for the flights here in Wisconsin. We were getting about 1 million points per square mile in a data set. That is a ton of survey points, completely impossible to do with boots on the ground. As the new federal specs came out, we've started to upgrade the Wisconsin data sets. So those are going to be 2 points per meter and have a 0.3 of a foot vertical accuracy. And with all those points in that same square mile of data, instead of 1 million points per square meter with the newer sensors, the standards, we're looking at 13.5 million points in that same tile of data. Now that's going to be on the ground, above the ground, but it's a lot of points, and you're going to have to figure out, what do we do with all of this data? Now, some municipalities and even counties in the state of Wisconsin have moved closer to what we call a quality level 0 standard. So that's going to be 30 points per square meter on the ground. That takes you from 13.5 million to over 300 million points on the ground per square mile. A lot of data. Terabytes and terabytes of data. So this gets me back to where I started, the frustration of this critically important data for all these purposes that I already talked about and more. But it's incredibly hard to use. Many people don't even know they have it. Why? It's siloed for many purposes, right? The data is slow. If you have brought in a LAS file into ArcMap, you might as well go get a cup of coffee, drink it, go talk to your coworker, get your other cup of coffee, come back, sit down, and that tile might have drawn in your map by that point in time. Really hard to do your day-to-day work like that, or you're going to be far too caffeinated by the time you do. Obviously, you need to use expensive software. Nothing wrong with Esri, but you can't give full Esri licenses to everybody in a county, everybody in a municipality, everybody in your engineering office, much less the general public. The size of the data is huge. Servers inside of office buildings just aren't always ready to take on another 3 or 7 or 13 terabytes of data, depending on the project that you're talking about. And LiDAR's kind of specific. People don't have training to understand what it is, how to use it, the idiosyncrasies of it. But in general, it's actually pretty simple data. It's an XYZ. So we got to make it simple, because right now you've got underserved users, people that should be using this data. Like I talked about before, even the general public should have access to this data because it has a general interest. Why am I getting water in my basement? Highway engineers should be using this. Environmental scientists should be using it. Planners, surveyors should be using this. Administrators of municipalities and counties should be using this data to help serve the public, understand the problems themselves. These are maps. They're just three-dimensional maps. They help tell the story of what's going on. And obviously the general public can have access to this data too. So the goal is, how do we make this easy? How do we make it simple? How is it cost effective? We can't charge everybody for this. So at AIRS, we started to try to come up with tools over the last couple of years. And earlier last year, we launched our beta products for this. So I'm going to jump out of my PowerPoint presentation here real fast. So now you should see our AIRS LiDAR online. This is Door County. We actually just launched this one last week. We're looking at all of Door County. We're looking at all of their LiDAR data. This was a 2018 project. And we've got our high vegetations, and you can see the buildings in red. We want things to make sense. General in these LiDAR data sets, you see ground, high vegetation, and buildings. So how do we do it? Well, we're just going to click on a slide. This is an Esri-based system, so most people are going to be pretty familiar with this. We've just zoomed into Cana Island here. You can see it's pretty neat looking. It's a flat island, but we are very much in a 3D space, and we are looking at an entire point cloud. We're not just loading, a couple tiles here and there. You can watch that redraw rate far faster than anything you'd natively see in ArcMap or ArcPro. I can jump around the county. It's kind of a fun experience, that video game experience that people are kind of used to, but just really hasn't caught up in the mapping world. I can zoom into this space. I'm just using my right and left mouse button, my scroll wheel to come in and out. And these are some pretty cool bluffs, but I don't see my points. I can turn those on. Look, boom. All of a sudden that nice bluff, you can still see it, but it's really hidden. So I just want to turn that data on and off. You can see my buildings in red. Move through. I can utilize this data, although this is not an analytical tool. This is all survey data, so it's very measurable. I can start a new measurement and see, okay, from this building, how far and what's the height off from the lakeshore here. So I'm about 111 feet from the lakeshore, and that elevation change is about 42 feet. It's a pretty powerful tool if I'm just a quick zoning administrator that needs to make a quick measurement or a quick decision. We're not just looking at trees. We can get into Sturgeon Bay here. You can see their bridge. You can see we're looking at our colorized buildings right now. I can turn those red just so they're a little easier to see. This works in the city environment too. And again, all in that 3D space. This is a simple tool, but what needs to be hitting home with you is how quickly the data draws, how good it can look. So we're over on Rock Island. In this case, Door County has a lot of karst topography, so we're mapping their depressions for them. In this case, we've got a 53.5-foot deep depression here on Rock Island. Rock Island is mostly forested. I'm guessing if we turn that on, yep. So that depression exists within the forest. It's important to know we don't have any buildings in there, which is good. There's no lack of neat places to look in Door County. So this is a really neat experience. I mean, even from an economic development or tourism fashion, to be able to enable a tool like this so people can almost explore the landscape before they get to the county for their weekend vacation. It's got a lot of potential. You can see potential from forestry, planning and zoning, like we talked about. The LiDAR data gives you access to a wonderful DEM. We can see we can lay the contours on the DEM to give a more natural feel to it. People are really used to seeing contours on their maps. But again, this is a 3D space. We've got our contours on here. We've got depression contours, and we've got our normal index contours. Again, I can take a measurement. Doesn't have to be from a building. I can do it from the surface of the land too. So I can see, all right, how deep is that bowl from the peak of the dune down into that depression? So you got about 57 feet there. So quite a powerful tool from a measurement standpoint. And jump over to another county. You can see I'm just in a browser here. So these data sets are online. They can be looked at. This is more of a pilot project that we have, and just to view some of the other data that is being created. With this LiDAR data, obviously we've still got contours in our map. We can draw full LiDAR data. Again, all of our trees are drawing, all of our houses are drawing rapidly. We can turn on our culvert data, like I talked about before. The culverts, we can try to take a look and see if we've got depressions in here. We do. You can generally see you're not going to get depressions where there's a culvert draining it. I think in this county we mapped something like 33,000 culverts. But we can also do other things. Environmental layers. DNR has their eval tools for doing their erosion. So we can see these draw. So we've got our contours. So we can see the steepness. Turn off my contours. And turn on our stream power index. This is going to be a key feature for understanding where water is flowing across the surface of the earth, not always annual streams, but where water flows, how forcefully would it be flowing. With that data, you can start to see where we have soil loss potential. How does that relate to that stream index? If I turn those off, then I can start to get into erosion vulnerability index across entire watersheds for, in this case, I believe a 12 watershed. This data can be created relatively simply, assuming I've got 1, a good LiDAR data set, 2, the culverts we looked at so we understand actual drainage, and then 3, just the process to create the soil erosion model. It's not just soil erosion that can be created. We can understand slopes. In this case, from a conservation standpoint, it's really important to understand our 6, 12% and 12% plus graded slopes. That could be for erosion, it could be road embankments, it could be stabilizing stream embankments, those types of features. We can also look at forestry applications. Maybe I want to find trees of a certain height, and this could be for species identification. It could be for cutting for timberlands. And I can pretty quickly look across an entire county and try to find all trees that are 80% or higher across the county. So that could be very useful from a forestry standpoint. Again, a relatively easy things to do once you've got that base data, and you don't need to have expensive software. I can have this all in a non-named user Esri environment right from the web. I can do this from my phone. So you can see the power of this. We expect data to get bigger and bigger. We've actually taken steps. What we're looking at here is a 30 point per meter data set that we created. This is just across the border over in Minnesota. But even at 30 points per square meter, if you guys remember that slide that we looked at before, over 600 million points per square mile, this is what you're looking at. So it works really well. It draws really fast. If you understand that data and you can put this key data into the hands of decision makers right away, they can do this from their phone, and you get a near world, real world life experience with a product like this. This is just using Esri tools. Here we've got a solar farm. It's like you were there. So you can experience the field before you go into the field. Save that time, get much more done in the office, be more directed once you're out in the field with a data set like this. So don't be afraid, test the data, use it, and we've all got to find ways to get this data in the hands of as many people as we can.